Okay, now we enter the second part of combinatorics, that is using something called binomial coefficients. This part includes permutation, factorial, division rule, combination and binomial coefficient, binomial expansion, binomial theorem, and also trinomial and multinomial. So let's talk about permutation and factorial. First, permutation. So suppose I have A, B, C, D. I have four things. A permutation is denoted as pi. For example, I have B, A, C, D. So in this case, I swap these two guys. So this is a permutation. And usually people denote it as pi. In this course, this is not very important. So I just let you know, permutation people denote as pi. But for us, it is not important. Okay. And what is permutation? A permutation is an ordered arrangement. So basically, A, B, C, D and B, A, C, D are not the same thing. So we consider A, B, C, D and B, A, C, D are not the same thing. Or in other words, let's say A, B is not the same as B, A. Then this order, A first, B second, and this order, B first, A second, are not the same thing. Then we call it a permutation. I give you four things. So A, B, C, D, how many permutations are there? So we can do it by what? By brute force. So A, B, C, D, A, B, D, C, A, C, B, D. So these are all the things starting from A, and then you repeat this for all the things start with B, and you repeat this. Then in the end, you have a lot of numbers. So how do you get this number? So here's an important thing. The number of permutation of an n set, that means n distinct object, is n times n minus 1 times n minus 2 up to 1. This can denote as n factorial. Okay. So what is the use of permutation? So before I go to this, let me talk about what's permutation. The k permutation, okay, k permutation of an n set, okay. So what is this? For example, k is 3 and n is 5. So I have A, B, C, D, E. This is 5 thing, okay? This is 5 thing, okay? My set is 5 thing. And then k is 3. That means I have 3 boxes. I can pick stuff. And how many permutations are there? Then the number of permutation, okay, will be what? The first guy, how many ways I can choose the letters? Well, there are 5. So I can choose 5. The second guy, one of them I've been chosen, so I cannot repeat. So I take 4 and then I take 3. So basically it means every time when I pick one thing, the next box I will have one less element to choose. So in this example, the number of permutation is 5 times 4 times 3. So it will be n times n minus 1 times n minus 2. And in this case, this guy is what? N minus k plus 1. K is 3, right? Negative 3 plus 1 is 2, okay? So therefore, this is the number of k permutation of an n set, okay? This means I can have k objects. They are all distinct. They are all distinct from an n set, okay? But what about if we allow non-distinct object? So non-distinct object, for example, how many permutations can be formed from the letter happy? So here's the trick. You first treat those PP as 5 distinct letters. So you add a 1 and a 2 subscript here. So now P1 and P2 are different things. You treat them as different things. So how many permutation of this happy? So you have 5 letters. So there are 5 factorial. This number of permutation for this thing. But within these 120 permutation, you double count some of them. For example, HAPPY, these two are all HAPPY. The difference is only the order of the P. P1, P2, this is P2, P1. And similarly, for this PHAYP, you just swap the P1 and P2, you get the same string. And originally, you don't have P1, P2, you have just 2P. They're the same thing. So you have double counted twice. So you have to divide by 2. And actually not divide by 2, divide by 2 factorial. What does this 2 factorial mean? This 2 factorial means how many permutations you have from this P1, P2. So how do you see this 2? You can think of it like this. I ignore everybody in outside. Then this gives me P1, P2. If I ignore everybody here, what is this? I have P2, P1. So P1, P2, P2, P1 is the same as how many permutations I have for the 2P. Okay? So this is a formula. So what is this? 120 is 5 factorial. 2 factorial is in the denominator. This is actually something called division rule. Okay? You divide something, you double count it. You divide those things, you double count it. Okay? And the general form of this will be n factorial divided by a bunch of factorial, which this n1 factorial, n2 factorial, n3 factorial are the number of repeated objects. Okay? So this is one example. Now I'm going to repeat this example 3 times so to make you understand this clear enough. So suppose I have this 1, 1, 2, 3, 4. So first we assume the 2 ones are distinct. So we add A and B in the subscript. So now we have 5 things because 1A is not 1B, okay? Then what's next? We have 5 things. How many permutations are for 5 objects? 5 factorial. So 5 factorial is 120, okay? But again, within this 120, we double counted some cases. For example, for 1123, this permutation, notice that in our original setting, there's no A, B here. So we cannot distinguish whether or not the first one is 1A or 1B. We have no way to know. But in this permutation, we add label 1A and 1B. So actually we have 2 cases here. The first is 1A, 1B, and then 2, 3, 4. The second case is 1B, 1A, and then 2, 3, 4. But as I said, in the original case, we don't have those A, B label. So we don't know if we see a 1, 1, 2, 3, 4. We don't know which is which. So we actually have double counted. We have to cancel the double counted one. So we have to divide by 2. And this is another example. So suppose we see a string 1, 2, 1, 3, 4. Okay, again, we have no way to tell is this one 1A or is this one 1A. In fact, there are 2 possibilities, and we double counted the 2 possibilities. So in the end, we will have this number. What is this number? Let me repeat. This 5 is how many number in the distinct object. That is, we treat them as 5 distinct objects. So it gives us the 5 factorial. What is this 2 factorial? This 2 factorial is we have double counted the 1A and 1B permutation. And how do you see that? How do you see this 2 factorial? Well, you erase all those other guys. You erase all the other guys. So this one gives you 1A, 1B. This one gives you 1B, 1A. And if you replace the symbol 1A and B by XY, so this is basically XY, this is YX. So what is this? This is actually the 2 possibility you can get for permuting a 2 set, right? So this is the 2 factorial, okay? And if you put into the formula here, this is how you put n is 5, r is 1 type of another object for 1, and then n1 is 2. So you have type 1 object, that is the 1. You have 2 of them, so n1 is 2, so you have a 2 factorial, okay? So now, the same example, 1, 1, 1, 2, 3, okay? 1, 1, 1, 2, 3. Again, you first treat them as 5 different things. You add label A, B, C. So you have 1A, 1B, 1C. Now, when you see the string 1A, 1B, 1C, you will count them in 5 factorial way. But in the end, when you see the string 1, 1, 1, 2, 3, you don't know which are these 3 ones. It can be what? ABC,
ACB, BAC, BCA, CAB,
CBA. So what does it mean? It means all these possibilities are giving you the same 1, 1, 1, 2, 3. You don't know which is which. So that means in this 5 factorial way, you have double counted all this amount. So what is this amount? If you cover up the 2, 3, what is this? This is basically the permutation of ABC. So this is ABC, ACB,
BAC, CAB, and CBA.
So what is this? This is 3 factorial. So therefore, you have double counted 3 factorial, which is 6, right? There are 6 cases. So how many number of permutation for 1, 1, 1, 2, 3? In the end, it will be 5 factorial divided by 3 factorial, which is 120 divided by 6. That means you have only 20 of them. Okay? And if you plug in the formula, so n is 5, n is 5. What's r? R is number of repeated type. So you have one type of thing being repeated, that's 1. And then how many of them? 3. So n1 is 3. So you have this. Okay? The last example. So suppose you have 1, 1, 1, 2, 2. How many possible permutation of them? The first step is you add label A, B, C in the 1, and you add label A, B in the 2. And then you treat them as 5 different things. So you have 5 factorial way to permute them, which is 120. Okay? But again, if I give you 1, 1, 1, 2, 2, you have no idea which is which, because it's possible you can have this or you can have this. Then how many ways you have double counted? So it will be how many ways you have double counted the 3 ones and how many ways you have double counted for the 2s. So how many ways you have double counted 1? There are 3 ones, so you have the 3 factorial. How many ways you have double counted 2? You have 2 factorial. And the number of ways you count double 1 and double 2, they are what? They are Cartesian product. They are not related to each other. So you have a product rule. You multiply them. And this 3 factorial, 2 factorial means the number of ways I have double counted the 1 and also double counted the 2. Okay? And these are double counted. Then by the division rule, I have to remove them from my 5 factorial. So in the end, this will be the formula. So it will be 5 factorial divided by 3 factorial and 2 factorial. Okay? So this is the number. So what's the number? 5 factorial is 120. 3 factorial is 6. 2 factorial is 2. So in the end, I have 10. Okay? So that's the number of ways you can permute 1, 1, 1, 2, 2. Okay? You should now understand what the heck is this. So I have a bunch of objects. So I will put the number of objects on the top and take a factorial. And then for each type of repeated objects, I will have the factorial in the bottom until I have go through all the type of repeated objects. Okay, so this is the formula for repeated objects in a permutation. Okay, and magically, this thing actually is the multinomial coefficients. And then here's an example. So what is the setting here? So you know, in a Olympic game, people will what? The winner will stand on the stage and then the flag will raise, right? So they will raise the flag, right? Okay. So now suppose I have a game with 10 competitors in chess, and then 4 are from Russia, 3 are from United States, 2 are from UK, and 1 is from Brazil. So suppose I have this kind of ceremony. When they win, the flag will raise. Then the question is, how many possible permutation are there if I list the result in their nationality? That means what? That means suppose I have 4 Russia, and let's say the Russian are all the top 3. Then I will have 3 Russian flag here, right? I will have 3 Russian flag here. And then this is one possibility of the outcome. But what about if one of them is Russian and 2 of them is United States? Then you have different permutation. And turns out this thing is basically the multinomial coefficient. So you have 10 competitors. So if you treat all these people are distinct, then you have 10 factorial permutations. And in this permutation, you have double counted 4 Russian. So 4 factorial have to be divided. 3 factorial have to be divided for the US, 2 factorial have to be divided for the UK, and 1 factorial have to be divided for the Brazil. And this will be the total number. Okay? This is saying that, for example, if it is UK, US in the top 3, okay, then so on, this top 3, and then you have the 4th position, 5th position, 6th position, and so on until you have a 10th position. So if I get this, again, there are 2 from UK. So you don't know is UK A first or UK B first, because okay, it's possible you have UKB get before UKA, right? So you have these 2 possibilities, and you double count in this 10 factorial. That's why you have to divide by 2. Okay. And then okay, this one is not in exam.